Alright, this is the back of the review sheet for Unit 10 log test. We're going to look at number 27 through 29. Let's go over what the directions were again. So right above that on the first page it said solve the exponential equation, express the solution set in terms of the natural logarithm. So again, these three problems we're going to leave all as a natural log. For some reason I didn't space these out, so I'm going to do all three of these on a separate sheet of paper. So 27 says 2 to the x plus 4 equals 5. Now, because there's no e for this particular problem, you could log instead of ln. However, Ms. Puckett used ln on the test, and the directions said to leave everything in terms of natural logarithms. So just like earlier, our goal is to bring this exponent with the variable in it down front. So I'm going to go ahead and bring it down. X plus 4 ln of 2 equals ln of 5. Now earlier, when we were working the front side, we kept getting ln of e, ln of e, ln of e, ln of e, and it would equal 1. Well, this time, because there's no e, nothing's going to go away. So we're going to have to treat this problem a little bit differently. So what we're going to do is we're going to distribute each of these terms and multiply it by the ln of 2. So x times the ln of 2 is x ln 2. 4 times the ln of 2 is positive 4 ln of 2, and it equals ln of 5. Now I'm trying to get the x by itself, so the first thing I'm going to do is move this plus 4 to the other side. Since I'm moving the plus 4 to the opposite side, I'm going to subtract it. So I get x ln of 2 equals the ln of 5 minus 4 ln of 2. Now I have x times the ln of 2, so I'm going to divide everything by the ln of 2. So these cancel out, and x equals the ln of 5 over 2 minus these two ln's are going to end up canceling. So the ln of 5 over the ln of 2 minus 4. And that's our answer. And we're going to leave it just like that. Okay, let's go look at 28. 28 is going to have the same process. So I have 5 to the x plus 3 equals 7. Again, I'm trying to solve for an exponent and variable that's an exponent. So since I can't get like bases, I need to bring it out front. The only way to do that is to take the natural log or the log of both sides. Since it's not an e, I can do either, but the direction said leave it in terms of the natural log. So x plus 3, natural log of 5 equals the natural log of 7. Just like we did earlier, because this is not the natural log of e, nothing goes away, nothing equals 1, so we have to go distribute each of these terms. So x times the ln of 5 plus 3, the ln of 5 equals the ln of 7. Again, we're trying to get x by itself, so I need to move this to the other side, so we're going to subtract. So x ln of 5 equals the natural log of 7 minus 3 times the natural log of 5. The last thing we're going to do is divide everything by the natural log of 5. So we get x equals the natural log of 7 divided by the natural log of 5 minus 3. Alright, last one of these, number 29, it says 7 to the x plus 1 equals 3. So this would probably be a great time to pause the video and try this one by yourself and then come back and check. So if you're coming back to check, hopefully, you've brought the exponent out front by taking the natural log of both sides. You've distributed each of these terms to the natural log of 7. You've moved this 1, I didn't write the 1, but 1 times the natural log is just the natural log. We're going to move this to the other side by subtracting. Okay, and then we're going to divide everything by the natural log of 7. These will cancel, so x equals the natural log of 3 over the natural log of 7. And these are going to cancel completely, so it's minus 1. Sorry about that. So so it's minus 1. They cancel completely. Okay, so these next few problems are what we did this week. 30 through 31 for each of these, it says find me among, I don't know, I guess that's because I'm so tired after taking care of my child with the flu. This should be find the amount that results from the investment. So remember, I'm going to be giving you some formulas, and you're just going to have to figure out which formulas to use. Because they want me to find an amount, I'm either going to use this formula right here, A equals P times 1 plus R over N raised to the NT, or I'm going to use this one that says A equals P times E raised to the RT. If you see the word compound continuously, you use the one with the E. If you don't see compound continuously, then we're going to use this one right here with the N's. Okay, so here we go. It says $12,000 is invested, that's your P, at 14%. Remember, 14% means 0.14. We move our decimal 2 to the left. Compounded annually, that means N equals 1, after a period of 9 years. So because we have an N and not the word continuously, we're going to be plugging into this formula right here. So the formula says A equals P, which is 1200, parentheses 1 plus R over N raised to the N times T. And at that point, you just type it in your calculator. There's no magic to it, you just do it. So 1200, 1 plus 0.14 divided by 1, and obviously you don't have to put divided by 1, we all know that that's going to be, and I'm still going to do the 1 times 9 even though I know it's 9. And we get $3,902 and, because we're talking about money, 34 cents. So we've got $3,902.34. Okay, next problem is going to work very similar. It says we have $16,000 invested at 11%, compounded semi-annually after a period of 6 years. So again, it didn't say continuously, so it's the exact same formula that we did up here. So A equals 16,500, 1 plus 0.11 over 2 to the 2 times 6. And again, we just type it in our calculator. So we got 16,500, 1 plus 0.11 divided by 2 raised to the 2 times 6, which is 12. Again, I know you can do this in your head. I'm just showing you how to type it in. And for this answer, we got a grand total of $31,369.92. Okay, next one. $3,000 is invested at 12%, compounded quarterly after a period of 11 years. Again, the exact same formula. So A equals 3,000, oops, let's do 3,000. 1 plus 0.12 over 4 raised to the 4 times 11. Again, you just type it in, but you have to know which of these formulas to go grab. These raised to the 4 times 11. Okay, so we have $11,014.36. All right. On 33, 34, and 35, they're going to ask me to find what's called the effective rate of interest. And we talked about doing this, that when we did this, there are a couple things you have to remember. Anytime you do effective rate of interest, we're going to let P equal 100, and you're going to let T equal 1. You're going to solve for A, and then you're going to remember to subtract 100. And then whatever your answer is, that's your percent. You have to know this process. It will not be written on there for you. So this is something you have to know. On 33, 34, and 35, I did forget to tell you what rate we were going to use for all three of these. All three of these, I'm going to use the exact same interest rate of 5%. So for all three of these, I'm going to use the same thing. So it says I'm going to solve for A. So I'm going to write A equals, and they want me to compound continuously. Because I see the word continuously, I'm going to use the A formula that has the E in it. So I'm using this one right here. P times E raised to the RT. So remember I said my P has to be 100, and they're not going to tell you that. Oh wait, I don't need to put my percents, they're all right here. I don't know why I said that earlier. Oh, it's for a different problem. It's from when we get down here. Sorry. 100 times e to the r, 0.08, and I said t was 1. Okay, so if we could type that in our calculator, we're going to have 100 times e raised to the 0.08 times 1. So we get $108.33. A equals 108.33. So it says solve for A, subtract 100. When we subtract 100, I get 8.33. Because I used the magic number of 100, it's 8.33%. That's the whole reason we're using that number. All right, next problem. Exact same process, but this time we're going to compound monthly. So we're going to use the equation that we used earlier that doesn't have the E, the one that we used up here, the one with the N. So again, we're starting off with $100. 1 plus 0.0625. Monthly means this is 12 to the 12 times 1. We're going to go type that in. 100 parentheses 1 plus 0.0625 divided by 12 raised to the 12 times 1. We get 106.43. I'm going to subtract 100 from that. 6.43%. Okay, last one. Notice I've done 3 of these. There's going to be 3 of these on the test, so you have to be able to do this a bunch of times, so it's really important to memorize these steps. Okay, quarterly means I use this exact same formula I just did, but where the 12s are, I'm going to replace them with a 4. So A equals 100, 1 plus 0.145 over 4, because it's quarterly, to the 4 times 1. So one more time, here we go. So 100, 1 plus 0.145 divided by 4 raised to the 4 times 1 equals $115.31. We're going to subtract 100, and we're going to get 15.31%. Okay, so again, there are going to be 3 of those on your test. The next 3 is where I left off my percents. So you'll notice every one of these, I give you an amount, I give you the years, I tell you how it's compounded, but for all 3 of these, for some reason, I left off the percent. So we're going to work all 3 of these at a 5% rate. Okay, so on these 3 problems, they want me to find the present value. So they want me to find P. So I have 2 equations right here for P. I have the one with the N, and I have the one with the E. If it says continuously, we use the E one. If it doesn't, then we use the N. Notice these equations are very similar to what we did earlier, but my exponents are now negative. All right, here we go. The first one wants me to compound annually. So P equals the 4,500 that we want, 1 plus, remember I said all the interest rates are going to be 0.05. Annually means N is 1, raised to the negative 1 times 6. Alright, so here we go. We're going to type it in. Just like earlier, except now these exponents are negative. So 4,500, 4,500, parentheses 1 plus 0.05 divided by 1, and I know that's 0.05, raised to the negative 1 times 6. And this says we started with $3,357, and that's going to round up to 70 cents. I'm sorry, 97. 97 cents. My fault. I don't know why I said that, 70. Okay, next problem. Exact same steps, but now instead of my N being a 1, it's going to be a 2. So P equals 5,000. 1 plus, we're using the same percent for the whole problem, divided by 2 to the negative 2, but this time we're for 7 years. I'm going to type that one in. So 5,000 1 plus 0.05 divided by 2 raised to the negative 2 times 7. We get that P equals 3,538.64. Alright, one more time. They want me to do it monthly for 16 years. So P equals, we're starting off with $35,000. No, not starting off with, that's what we want. We want $35,000. 1 plus 0.05, again, same interest rate. Monthly means N is 12 to the negative 12 times. This time we're going to do it for 16 years. So we're saving that money for a while. So maybe we're saving for a car since birth, I guess. So we want $35,000. 1 plus 0.05 divided by 12 raised to the negative 12 times 16. And we need to start with $15,752.67. Okay, 39 through 42 are asking me to find rates and how long something takes. Again, these require more paper than I gave you room for, so I'm going to solve them on a separate sheet of paper. So on 39, it says what annual rate, because it says annual, that means N equals 1. I'm looking for R. Rate of interest is required to double. Remember, double means A is 2 and P is 1 after 6 years. So I need an equation that will help me find R if it has an N, an A, a P, and a T. Well, I have two equations that have that. I can use this one right here. It has an A, a P, an R, an N, and a T. Or I could use this one right here that's got the negative exponent. I'm going to choose not to play with negative exponents, and I'm going to use this top one. So it starts off with A equals, so 2 equals 1, parentheses 1 plus R, that's what I'm looking for, over N, which is 1, raised to the N times 6. Then we're going to go simplify this, and we get 2 equals 1 plus R to the 6. From here it became an algebra 2 problem. I'm trying to get R by itself, but it's trapped by the 6. So I have to get rid of the 6th power. You're going to undo that by multiplying both sides by the reciprocal 1/6. We're taking the 6th root. So 2 to the 1/6 equals, those are going to cancel, 1 plus R. So R equals 2 to the 1/6 minus 1. Let's go see what that is. So 2 raised to the 1/6 minus 1 gives me 0.1225. 0.1225. So 12.25%. Or 12%. I'm just giving you the decimals. Okay. Number 40 is going to be the exact same process. So it's a good time to pause the video and try it and then come back and check it. So we're still doubling and we're still looking for N is 1. We're still looking for the rate. But this time the only thing that's changing is everywhere I have a 6, I'm going to replace it with a 3. So it really is to repeat. So on number 40, 2 equals 1 times 1 plus R over 1, because it's an annual rate that they want, to the 1 times 3. 2 equals, I'm going to simplify it up, 1 plus R to the 3rd. To get rid of a cube, we have to cube root, which means raise everything to the 1/3. I raise this side to the 1/3, and this side to the 1/3, those cancel. So 2 to the 1/3 minus 1 will give me R. So 2 raised to the 1/3 minus 1 gives me R equals 0.2599 or 25.99%. Okay. 41 and 42 are also problems that are similar. For both of these problems, they want to know how long it will take. So we're looking for T for an investment to double. So again, A is 2, P is 1. It earns 0.08 5, it runs 8.5% compounded continuously. Because I see the word continuously, I know I'm going to use the equation that has the E. So I need an equation that has an A, a P, an R, and an E. And I'm looking for T. Well, the ones that have the E in it are the ones that say continuous. Excuse me, right here. So I can choose which one. Again, I'm going to choose the one with the positive exponent. So 2 equals A equals 1 times E to the R 0.085 T. Well, 1 times E is just E to the 0.085 T. Now it's really familiar. These are just like the ones that were on the front of our review sheet. So in order to get this T to come out front, I have to take the natural log of both sides. And I know the ln of E is really 1, and 1 times 0.05. This is 0.085. So if I'm trying to get T by itself, I'm going to divide by 0.085. So T is going to equal the natural log of 2 divided by 0.085, which tells me T equals 8.15 years. Okay, so we're going to go do the exact same thing for number 42. Again, might want to pause the video and try it on your own real quick. So 42 again says how long will it take for an investment to double? If it earns 4.5%, so 0.045, and again, it's going to be continuously. So I'm using the same equation. So 2 is my A equals 1 times E to the 0.045 T. Again, that 1 times E is just E. We're going to bring that out front by taking the natural log of both sides. The natural log of E is 1. So we have the natural log of 2 equals 0.045 T. I'm going to divide by 0.045. And T is going to equal the natural log of 2 divided by 0.045, which is 15.40 years. Okay, almost done. Let's go look at 43 and 44. So 43 says the size of a certain population at time t in days obeys the function pt equals 5,000 e raised to 0.02 t. When will the insect population reach? That should say 8,000. Okay, so because we're talking about population size and we're talking about growth, we're going to use this equation right here, the growth and decay equation. A sub 0 e to the kt. Remember A0, that is your initial, and this is your ending population. Starting population, ending population. Okay, and for this particular problem, they did not give me everything. So let's go see what they did give me. A size of a certain population in t days obeys the function. Okay, this is my A0. This right here is my K. They want to know when will the insect population reach this. That means that's my ending population, AT, which means I'm solving for T. So I'm solving for this exponent up here. So 8,000 equals 5,000 e to the 0.02 t. So this is really similar to the problems we were doing over here when we were solving for t, except I don't have a 1 this time, so I have to divide these two. So I'm going to have 8,000 over 5,000 equals e to the 0.02 t. Then to bring this down, I'm going to take the natural log of both sides. So the natural log of 8,000 over 5,000 equals 0.02 t ln of e. And the ln of e is 1, and 1 times 0.02 is 0.02. So 0.02 t equals all of this. So ln 8,000 over 5,000 equals 0.02 t. So all I have left to do is divide by 0.02. So I go to my calculator and I type in all of this. So the ln of 8,000 divided by 5,000 divided by 0.02 tells me t is 23.5. Now this one's not years. I have to go read the problem. All the money problems were in years. 23.5, they tell me right here, days. So in a little less than a month, the population went from 5,000 to 8,000, increased by 3,023.5 days. All right, 44, last problem. Woohoo! The half-life of radium is 1,690 years. If 10 grams are present now, so that's my A0, how much will be present in 50 years? So that's going to be my time, but they didn't give me my K. So on this particular problem, I'm going to have to find the K before I can do anything else. So if we're talking about half-life, and I started off with 10, that means my AT is equal to 5. So I'm using that same formula that we were talking about earlier. I'm going to plug in. So 5 is the ending population because it was half of what we started with. E to the K, I don't know K, but I do know it takes 1,690 years to get the half-life. So this process is going to be the same as the one over here. I have to divide by 10 first. So 5 over 10 equals E to the 1,690K. Then to bring that down, I have to take the ln of both sides. And we've said it a bajillion times, the ln of E is 1, so this is really just 1690. So I'm going to divide both sides by 1690 to get K. So K equals, all right, let's figure out what K is. Now remember, K is your growth rate or decay. In this particular problem, since we're halving it, it's going to be decay. So I hopefully should get a negative number and it should be a decimal. So the ln of 5 divided by 10 divided by 1690, and we get this. So what you have to remember is when you see this negative, e to the negative 4, that's scientific notation, and it's telling me to take this decimal and go 4 places, 1, 2, 3, 4 to the left. So that means K is negative 0.0004. Now that I know K, I can go answer this question of what will the population be in 50 years. And I'm going to go back and use this formula. So in 50 years, the population started at 10. There's always an E here. My K is negative 0.0004, and this time I want to do it for 50 years. And I want to know, well, how much is going to be left? So 10 raised to the negative 0.0004 times 50, and my population is going to be 9.80, and what are we talking about? Grams. All right. Alright, so we have now worked the review page front and the back. I hope this helps. Study hard, and I'll see you tomorrow.